All right, this should be a little shorter video, and then just at the end, you'll get the intro to the research paper for this week, which we've already gone over a little bit of the data together. So I'm hoping that facilitates the reading process for you this week. So for diabetes, outcomes could mean preventing new cases, delaying complications. Oh, I used the same question here, you guys. So lame of me. Still a legitimate question, but I'm gonna skip that, and I'll change it for next semester. Sorry about that. I like to start each question, each section with like a question or something. You'll note that this looks really similar actually to the obesity section though. There's a reason why, because a lot of the mechanisms overlap, right? So, and also the reason I don't focus as much on like data here is that a lot of mechanistic research is not epidemiologic research, like we talked about, right? I'm going to expect much smaller sample sizes if I'm looking at mechanisms. So, but a couple of things that we would expect to see is improved vascular function. That's through angiogenesis, right? So, sprouting of new blood vessels, increased nitric oxide. Secretion, right? So improving my body's ability to vasodilate and help regulate blood pressure that way. Improved lipid handling, so increases in HDL, increased uptake and use of lipids or free fatty acids, decreased visceral fat tissue. So particularly in that regard, that's really important, right? Because that's independent of weight status. So I could see a decrease in visceral fat even if I saw no change in weight. Um, Maybe slight impact of converting white adipose tissue to brown adipose tissue. We really have in my from what I've seen, and it's not my area, but we don't really have enough data to suggest that there's a significant clinical impact from that yet. That it happens, that there's a mechanism there, yes. Uh, is it significantly impacting outcomes? I don't know. It's just a proposed mechanism. Improved glucose management. I've shown you a lot of data to support that. So we see increased uptake and use of carbohydrates, decreased liver glucose and cholesterol production, right? So that's that gluconeogenesis and glycogenolysis that we talked about being regulated. You see increased insulin sensitivity, right? Increased expression of that GLUT4 receptor. So even at lower levels of insulin, GLUT4 is likely to come there. Also during exercise, we have insulin independent movement of that GLUT4 to the membrane surface because of mechanical stress. Okay. Which decreases then pancreatic stress, right? Because those beta cells aren't overworking themselves producing so much insulin to try to get that blood glucose out of the bloodstream. So you also see increased insulin receptor number and density and function, so decreased, which all results in decreased insulin production. And then there's some interesting myokines involved that also improve insulin sensitivity. Okay, so lots of mechanisms there. I want to tie those mechanisms then into this picture, right? So where does physical activity then fit in here? And I've got a couple of areas for you. So first we have improved vascular function, right? So that's that angiogenesis piece, right? So hypoxia leads to increased inflammation, right? Some really negative impacts that result in increased fat storage in places where they shouldn't be. So that improved vascular function is happening there. We have improved lipid handling, right? So we see that increased lipolysis. Okay, our body is more capable of handling that if we engage in regular physical activity, maybe that higher intensity physical activity as well, right? We also see improved glucose management. Okay, so this mechanism over here, where we see that decreased LPL and increased HSL, that's going to be combated by exercise. We also see decreased or improved insulin sensitivity, therefore decreased insulin resistance, decreased inflammation, improved ability to handle reactive oxygen species. And also right here, right, that gluconeogenesis that the liver is doing when it's stored ectopic fat, right? As that then creates hyperglycemia, we see reductions in that, right? So improved glucose management fits there. And then we also see, oh, I should have put that the other way, but improved appetite coupling, right? So that positive energy balance might also reduce, right? So that data that I showed you last week, right? We may see improved, and I should have a line drawing that over to leptin resistance as well. But my body's response to hunger hormones is likely different as well as how much hunger hormones. So the sensitivity to, as well as the magnitude of release that's happening with those hunger hormones is likely impacted significantly with physical activity. Okay. So I wanted to just connect those pieces. So hopefully it doesn't all just feel like mumbo jumbo. I know there's a lot of areas going different places, but you've seen that figure now 3 times. So I'm hoping that the additions just focus on how mechanisms of physical activity interrupt the etiology of the disease. Okay, this is going to be really quickly, but there are different factors that contribute to health status, right? So the two that this article focused on were societal factors and physiologic factors. I just want you to think about all of the different things that could be affecting health. So this is not specific necessarily to type 2 diabetes, but you've got all of these different genetic factors and epigenetic factors as well. You've got tons of different endocrine, so hormonal factors, right? We've already talked about different adipokines and cytokines, right? TNF alpha should be really familiar. Different interleukins. We've talked about leptin. We've talked about CRP, right? So I'm hoping that some of these things are starting to sound familiar, right? But you've got all these physiologic factors that are impacting health, but then you've also got societal factors, so different family factors and environmental factors. So then the question becomes, okay, how do I help people be physically active? So this study tried to answer that. And what they found was that intrinsic motivation, self-efficacy, perceived barriers, difference between self-ideal body size, impact on quality of life, and duration of weekly moderate to vigorous physical activity all predicted 3-year weight change. Okay, so this data on the left is what that's looking at. So people with a high exercise autonomous motivation, right? So that intrinsic motivation, their likelihood for achieving greater than or equal to 10% weight loss was much higher than those with low motivation. So 10.7% of those with low intrinsic motivation and 35.7 with high intrinsic motivation achieved that weight loss goal. When looking at barriers, right? People who perceived low barriers, 22% achieved that goal. People who perceived high barriers, only 5% achieved their greater than or equal to 10% weight loss goal. Okay. And that impacts how you work with someone, right? How do I talk to someone about their barriers and how do I help to essentially eliminate or help them work through some of their barriers? This is looking at low self-ideal body size discrepancy, meaning, right, the difference between how I am versus how I think I should be is low. Those individuals were much more likely to achieve greater than or equal to 5% weight loss than those who had a high discrepancy. So again, this is one of the reasons why like shaming people, there is absolutely evidence, and this is part of that evidence, but that suggests that shaming people for being fat does not work. It's not going to help them lose more weight. In fact, it decreases the likelihood that they will lose weight. And then this was looking at, oh, this is just motivation again. Okay. So in any case, you can see there's a lot of different factors that go into actually helping someone be. So we need to know, okay, what's the effective intervention first, right? And we talked about the different FIT-VP aspects of what would be helpful for decreasing incidence of diabetes, and we talked about it for obesity. But you also then need to be aware of, okay, but then how do I actually help people do those interventions, right? And this is how we help them be intrinsically motivated. We help decrease their sense for uh, their sense for how many barriers they have to engaging in physical activity. We also help promote healthy self-image, right? Like these are all things that we can do to influence outcomes. So quick review, we covered a lot here. So the scope of the problem first, 38 million adults have diabetes, and the prevalence is rising worldwide. Costs exceed $400 billion a year in the US, and there are lots of complications, including kidney disease, neuropathy, retinopathy, and cardiovascular disease that can come as a result of type 2 diabetes. Chronic energy balance leads to ectopic fat storage and insulin resistance, and that process also results in increasing cytokines. So TNF alpha and IL-6 increase inflammation and impair insulin signaling, as well as overstress beta cells in the pancreas, which can ultimately result in beta cell failure and the inability to produce insulin. Type 1, though, is different etiology, right? It's autoimmune destruction of the beta cells. The role of physical activity prevents or delays type 2 diabetes. You see 25 to 50% lower risk, depending on the data that we're looking at and the outcome we're looking at. We do see improved insulin sensitivity, glucose uptake, and lipid handling. We see pretty clear dose responses, especially with frequency, definitely some compelling data with intensity. Duration and volume of physical activity. So volume and frequency for sure, we see that dose response. Intensity, I didn't really show you data that would suggest dose response, but for sure a response. And then similarly with duration, we just looked at sort of greater than 150 or less than 150 minutes a week. For exercise prescription, we would prescribe greater than or equal to 150 minutes a week with no 2 consecutive days inactive, right? So we're getting that volume piece and the frequency piece. Weird. It's like we just talked about how those are effective. Vigorous physical activity would be more effective, but I would avoid it with retinopathy. Resistance training, I would progress slowly to avoid injury risk with tendinopathy, right? Glycation of those tendons. Safe glucose ranges would be 90 to 250 before starting, and avoid insulin injection right before, because then you're likely to have a hypoglycemic episode. Um, Continuous glucose monitors, as well as sequencing and modalities, right? That vigorous before the moderate, actually, which is not what we would typically see, right? We would typically, start somebody like with a warm up, and I would still start someone with a warm up, but I would jump into that vigorous pretty quickly with someone who has diabetes as opposed to normal, like a metabolically normal population. Couple landmark studies, the diabetes prevention as well as the diabetes prevention outcome studies. Pretty interesting. Lifestyle led to a decreased incidence of diabetes by 58% as opposed to the metformin just resulting in that 31%. But when we look at that 20-year data, right, we saw a lot of confounding variables that may be introducing what we'd call noise into the data, but ultimately not super different outcomes between the three groups. But remember, all three groups were receiving that lifestyle intervention then. Okay, jumping into article specific content.